Hello and welcome back to section 4 of this course. In this section we're going to look at some of the computer vision and AI technology used in self-driving cars, specifically an approach to predict the steering angle based on a feed of images of the road ahead. In this section we're going to cover the kind of technologies that we'll use, we'll download and use a dataset, set up an environment, we'll explore our data, we'll train our model, and then we'll test our model to see how it behaves. First, let's start with a very important note, that this code is not designed for real-life usage. There are a large number of safety features that a real autonomous vehicle has that we won't cover here. However, this section is designed to introduce you to an approach to do this, and can help you get started on a career in this space, if you so wish. So let's look at what's known as convolutional neural networks. So how can we predict the steering angle of a car? Predicting the steering angle can be done in a number of ways. It is possible to detect the lines in the road using computer vision techniques, calculate any angle in them, and use this to determine an appropriate steering angle. Another approach is to use deep learning. We are going to use a convolutional neural network to learn patterns in road images and predict steering angles. And our training data will consist of multiple road images and corresponding steering angles captured from a real car. So what are convolutional neural networks? Convolutional neural networks, or CNNs for short, are a class of deep, feed-forward artificial neural networks, most commonly applied to analyzing visual imagery. They're inspired by biological processes in that the connections between neurons resemble the organization of the animal visual cortex. Individual neurons respond to stimuli only in a restricted region of the visual field, known as the receptive field. The receptive fields of different neurons partially overlap such that they cover the entire visual field. CNNs use relatively little pre-processing compared to other image classification algorithms. This means that the network learns the filters that were traditionally hand-engineered in other algorithms. This independence from prior knowledge in human effort in feature design is a major advantage. And for information, Yann LeCun, now at Facebook, pioneered the use of convolutional neural networks many years ago. The diagram at the bottom explains how some of this happens. You can see the input, a variety of feature maps, which increase in complexity, and then an output at the far end. Here's another example. So in this image you can see how a CNN has learned to identify edges and textures. This builds into higher level representations, such as parts of a car, then more complete images of a car before recognizing that, in this image, it's an Audi A7. None of these representations are programmed. The network learns all of these from training examples, and that's what makes them so powerful.